This is College Algebra, Test 3, Lesson 3. In this lesson, we're going to talk more about the properties of logarithms, delve into the product, quotient, and power rule, and then we're going to apply them. We're actually going to use them. Quick review of properties of exponents. We covered before how logarithms are exponents, so it makes sense. Let's talk about properties of exponents before we talk about properties of logarithms. Just notice in this scenario here, if you're multiplying two things together with the same base, you add the exponents. You could break it out and kind of see the reason why that works. If you have x to the fifth, that's simply x times x times x times x times x. X to the third is x times itself 3 times. If you write it out like this, you can count them and clearly see, oh, I've got 8 x's. X times itself 8 times. That's where the 8 comes from. Now, we wouldn't want to have to write it out like this every time. So that's why we kind of pick up on the convention. In this scenario, we add the exponents. If this was x to the 50 times x to the 30, I wouldn't want to have to write out x times x times x 50 times. I would just simply add the exponents together. In a similar fashion, x to the fifth divided by x to the third. Notice if you write out x to the fifth, that's x times itself 5 times. There's x times itself 3 times. Notice 3 of those x's cancel out, and you're left with just 2 x's. So clearly in this scenario, dividing, you subtract the exponents. All right, so a little review of property of exponents there. Let's see how that applies in the properties of logarithms. Notice here, if you have the logarithm of a product, you're going to end up adding the logarithms together. And remember what we said before, a logarithm is an exponent, so I am adding exponents here, log m plus log n. Let's see that in action. Okay, so in this first example here, I've got log base 6 of 7 times 11. If it was advantageous for me to split these up, I could. I could take the log base 6 of 7, and since they're being multiplied, I use addition with the log base 6 of 11. Or, and that's all I can do. I can't simplify log base 6 of 11 anymore, nor can I simplify log base 6 of 11. Let's look down here, log of 100x. 100 and x are being multiplied together, so I can separate it by doing the log of 100 plus the log of x. Again, they're being multiplied, so I use addition right here. Trying to make an arrow. Log of 100, however, we can simplify. The log base 10, this is a common log base 10 of 100 is 2. Log of x is simply log of x. All right, so that's how we could use the product rule to separate out logarithms of products. What about division? Well, just like with exponents, when you divide, you end up subtracting the exponent. So here, if you have the log of a quotient, you end up subtracting the exponents. Let's see that in action. So if I have log base 8 of 23 over x, then I can simply take the logarithm of the numerator minus the logarithm of the denominator. Log base 8 of 23, I can't simplify, so I simply leave it like that. Same with the log base 8 of x. On this next one here, the logarithm of e to the 5th divided by 11, well, that's going to be the natural log of e to the 5th minus the natural log of 11. Notice we have a natural log of e to the 5th. Recall last time, I know it was a long time ago, but here the natural log is the logarithm base e, and that's e to the 5th. That's an exponential base e, so those cancel each other out, so the answer is simply 5. And then we have minus natural log of 11. And then I think I mentioned before, the natural log of 11, we have to be careful here. If you look at that a different way, that could look like 1n11 or ln/ll, right? We have to remember in context here, we're talking about logarithms, so that's clearly the natural logarithm, and we're looking for a number right here, and the number is 11. All right, so this is a case where we would separate them out by subtracting using the quotient rule, and then we could simplify by using one of the simpler properties of logarithms. Now let's move on to the power rule. Quick review again about the properties of exponents. If you have x squared raised to the third power, okay, notice I don't have two separate bases. I have one base, it's raised to an exponent and then raised again. In this scenario, we multiply the exponents. X to the 2 times 3, or x to the 6. If we want to break it down like we did before, notice x squared raised to the third power, that means x squared times itself 3 times. That's what the to the third power means. And then each one of these x squareds would be x times x. And this x squared would be x times x, and that x squared would be x times x. So I can clearly see here on the bottom that there are 6 x's. Again, we wouldn't want to have to write it all out like this every time. We'll just simply pick up on the convention. If you have a base raised to an exponent raised again, then in that scenario, you multiply the exponents. So we can apply that property of exponents to logarithms. Notice if we have the logarithm of a base raised to an exponent, we can move that exponent out front. We can move that p out front. And so essentially what we're doing is we're multiplying this exponent p times the logarithm, which is an exponent. So in a similar fashion, we're multiplying exponents together here. Let's see it in action. So I've got the log base 6 of 3 to the 9th. So that 9, that exponent, I can move out front. That's it. This is the one that drives everybody nuts because they see log base 6 of 3 and they think, oh, I've got to be able to simplify that, right? Because 6 and 3 are just connected somehow. Well, they are. 3 plus 3 is 6, 3 times 2 is 6, but they are not connected exponentially. So when we're in this section here, for all the test 3, we need to be thinking exponentially. 6 and 3 are not connected exponentially, so you cannot simplify that at all. So it's just simply moving the exponent out front. On this second one here, the 2, the exponent simply moves out front. Very important point right here. This log of a sum, log of x plus 4, you cannot simplify. This is a very, very common student error. Please resist the temptation to distribute the logarithm. Okay, this is wrong. No, you can't distribute the logarithm. It's not like multiplication. So do not turn that into log of x plus log of 4. If there's a sum in there, there's no summation or there's no addition rule for logarithms. If there's an addition going on inside of a logarithm, you cannot do anything with it. And then this last example, I just want to stress the point that radicals and logarithms don't get along. So if you ever see a problem like this where you have a logarithm and a radical, first thing you want to do is convert the radical into an exponent. So the cube root of x would be x to the 1/3. So now I've got natural log of x to the 1/3. Okay, now I have an exponent. I can just use the power rule and move that 1/3 out front. Done. That's the power rule. So here's all of them put together. The product rule, if you have a product inside, you can separate them into 2 logarithms with addition. If you have a quotient, you can use subtraction. And if you have an exponent, you can move it out front. That's the power rule. So what if you have all of these things going on at once? So let me walk you through this one. So right here, the first thing that jumps out at me is the fact that I have this radical. I don't like radicals and logarithms, so let's change that square root of x to x to the 1/2. Okay, that'll take care of that problem. Now I just take it a step at a time. Looks like I've got the logarithm of a quotient. So let's break it up into the logarithm of the numerator minus the logarithm of the denominator. Just simply applying the quotient rule. Then inside here, it looks like I have a product. So I've got 25 times y cubed. So let's split that up into the log of 25 plus the log of y cubed using the product rule there. Now notice I am subtracting all of this. So I need to subtract all of this. That's why those parentheses are in there. So to get rid of those parentheses, let's distribute that negative sign. So that's why it's minus log of base 5 of 25, and it's minus log 5 of y cubed. I'm subtracting there. All right, now last step, I just need to deal with the exponent. So this 1/2 goes out front. Log base 5 of 25 just simplifies to a 2. And then here the exponent 3 can go out front right there. You know you're done with these when inside every logarithm there is no product, there is no quotient, and there is no power. There's nothing else you can do to expand that out. All right, so that's the use of all the properties at once. So here are the properties again, but notice something a little different. Now we need to learn how to do it backwards. Right? So before we took a log of a product and split it up by adding, well, what if I have 2 logs being added together? Well, I could condense it into a single logarithm by using the same rule, the product to quotient power rule. Any one of those I could use to condense into single logarithms. So we're kind of shifting gears here, going backwards. So for instance, on this first one, I've got the log base 25. I'm sorry, log of 25 plus the log of 4. Well, I can use the product rule. Since I have 2 logarithms being added together, I can condense it into a single logarithm with the product. So since they're being added here, I can use the product, 25 times 4. Well, 25 times 4 is 100, and the log base 10 of 100, this is the common log, is 2. So that all simplifies down to a 2. Sometimes there's not any simplification at the end. Here I've got the log of something minus the log of something else. So I simply use the quotient rule to do the log of the first one goes in the numerator, and the log of the second one goes in the denominator. Done. Here I've got all kinds of things going on at once. So first thing I want to do is take care of the exponents, the power rule. So this 1/4 out front will move up here to the exponent. That 1/4 moves to the exponent. This 2 moves to the exponent. This 10 in front of this logarithm goes to the exponent. Now I've got this logarithm minus this one minus this one. So I'm subtracting here. And I picked this example specifically because I want to illustrate to you. You're not going to make a compound fraction, right? You're going to take the log, this x to the 1/4 goes in the numerator because it's positive, right? There's no negative sign out front. This one, however, is being subtracted, so the 5 squared goes in the denominator. But because this is subtracted, you don't make another denominator and put it down below the 5 squared. Just simply, it's because it's being subtracted, you put the y to the 10th in the same denominator. All right, so whenever you have lots of them going on at once like this, if it's positive, it goes into the numerator. If it's negative, if it's being subtracted, it goes in the denominator. The x to the 1/4 we could change into a radical, and the 5 squared is equal to 25, so we could simplify it that way. You know you're done with these when you have a single logarithm and there's no number out front. Okay, if you have more than one logarithm, then you're going to be able to use the product or quotient rule to condense them. If you have a number out front, you'd be able to use the power rule. All right, one other thing we need to cover in this section is the change of base formula. This is just a formula, a relationship that exists between logarithms. Notice here, if I have log of some base b, right, whatever that number is, let's say it's a number other than 10 or e, right? If it's not 10 or e, we're in a little bit of trouble because those are the only logarithm numbers or buttons we have on our calculator. We have a log base 10 and we have a log base e, but if that b right here was like a 7, I don't have a log base 7 button on my standard calculator. So I can do the change of base formula. And what this simply means, I can change the base of the logarithm to anything I want, that a right there. I would recommend using 10 or e, but whatever it is, it's the logarithm of whatever number's inside here goes on the top, divided by the log of the old base. That's the kind of hard part to get your brain around sometimes. It's the b, whatever the b is, that's the old base. So To change the base of any logarithm, you're simply going to develop a quotient, the log of the number divided by the log of the old base. And so you simply have to remember which one goes on the bottom, where the base is already kind of underneath anyway, so that kind of logically means, oh, it goes on the bottom. Let us see that in action. All right. Oh, and this is just emphasizing that it would make sense to either use the common log here or the natural log. And the interesting thing is, it doesn't matter which one you pick, you will get the exact same answer. Let me show you here an example. All right, so I've got the log base 7 of 2,506. Like I said before, we don't have a log base 7 button on our standard scientific calculators. However, if so I can convert it to a common log. Notice there's no base written down there, so it's understood to be a 10. So that's the log of 2506 divided by the log of the old base. These two buttons I have on the calculator, so I could put those in. Just remember, when you do log of 2506, be sure and close the parentheses before you divide by the other log. If you don't, you got to close the parentheses to let it know, okay, I'm done with that first logarithm. Then when you put that in the calculator, you'll get 4.02. Interestingly enough, if you do it with natural log, you'll get the exact same answer. So you could pick either one, common log or natural log. It's simply remembering that the number that's inside the logarithm is in the numerator, and the old base is what goes in the denominator. All right, so those are the properties of logarithms that we need to get very comfortable with. Product rule, quotient rule, power rule. We need to be able to expand any logarithm that we're giving using any one of those properties. And if we're given several logarithms, we need to be able to condense them into a single logarithm by applying those. This concludes College Algebra Test 3, Lesson 3.